So, hello and welcome everyone. Welcome to another session on problem of the day. So, if I'm clearly audible as well as visible, can I get a confirmation in the chat box? Okay, so we'll be discussing the solution for the problem of the day, which was 21st of May, and the name of the question was bus conductor. Okay, so can I get a quick confirmation in the chat box if I'm clearly audible and there's no issue regarding audio clarity and video? Okay, I think my audio and video is perfectly fine. Hi Rishit, hi. So let me share the screen and we'll be starting the discussion. I hope my screen is visible to everyone. Okay, so basically this was the problem of the day. Yesterday's problem of the day, and the name of the question is bus conductor, and the difficulty level is easy. So how many of you were able to solve this question? So basically, this is like a standard question of an algorithmic paradigm, and it has been changed completely different into a different question by just changing the storyline. Okay, so it's completely the same standard question. So let's first of all quickly read down the problem statement. So the problem statement says you are a bus conductor and there are n chairs and n passengers in the bus. You are given an array chairs of length n, where chairs of I is the position of the ith chair. The array chair denotes the position of the chair, and the array passenger denotes the position of the position of the jth passenger. You can imagine a number line, and over there at different points, imagine passengers, imagine chairs, and it is possible that at a single point there can be multiple chairs or passengers. Okay, it is mentioned over here that there may be multiple chairs or passengers in the same position at the beginning. Okay, so what you have to do, you have to return the minimum number of moves. The passenger can move one step forward and one step backward. Okay, so he needs to sit on a chair. So what will be the minimum number of moves required to move each passenger to a chair? That means assign a chair to each and every passenger, and no chair should be assigned to more than one passenger. Okay, so two passengers cannot sit on the same chair. So that is the formal discussion on the problem statement, and now let's see the example. So let me copy this and let's see this. Is my OneNote visible? I hope it's visible. If not, then just mention it in the comment section. Okay, okay, I hope it's visible. Yeah, so basically these are our arrays, chairs, and so basically let's say imagine a number line. This is your 0, this is your x-axis, and these are 1, 2, 3, 4, 5, 6, and let's say 7 and 8. Okay, so these are the positions. Okay, and this is your number line, x-axis. Let me denote down the chairs using yellow color. Okay, so it is a 3 over here. I can see a chair, 1, 3, and 5. And now let's denote the passenger using blue line. Okay, so using blue color, this is my passenger at 7 also, and over here as well. Okay, so these are the number of passengers and their location, right? So now I want to assign a chair. So this passenger can go to this chair or it can go to this chair. Let's say this passenger is going to this chair. Okay, so it will be moving one step. Now this passenger has two options, this or this. Let's say he's going moving to this chair, so he has to move one position, and now this will be assigned this one. So in total you can see over here, by moving in this way, total number of moves required were equal to 3, right? And in the output you can observe. Okay, so did we make any kind of mistake? Let's see. 1, 2, 7 and 4. Let's see passengers at 2, 7 and 4, and the chairs at 3, 1 and 5. 1 and 5. Okay, so over here this will be two positions, not one. Okay, so basically 2, and the sum comes out to be equal to 4. So this is the minimum number of moves required. Okay, so now what I need to do, how to approach the question, right? And it is mentioned that at a single position then can be multiple number of chairs or passengers. Let's see example number 2 over here. This is the type of example which I am referring to, having multiple passengers or chairs at a position. So let's say over here, if I say in this one, 0, 1, 2, 3, 4, 5 and 6, over here it is mentioned that chairs are present over here. So let's say chair and chair, and one passenger is also present, this, this, and now at 6 two chairs are present and one passenger is also present, and at 1 what is a, it is passenger and 3 is passenger over here. This is my passenger. Passenger here and here. So now I need to find out minimum number of moves. Let's say optimally, if I don't know how will be the optimal approach, so let's say I'm trying out randomly. Okay, so let's say this passenger will occupy this chair itself, so it will be not moving any steps. So now let's say this passenger will be assigned this one, this chair. Okay, so now it will be moving one position, and now let's say this passenger will be assigned this one, so it will be 0, and now this will be assigned this one, so that would be 6 minus 3 will be 3. So in total 3 plus 0 plus 0 plus 1, that comes out to be 4. Again, let's see the output. We can see in the output comes out to be same. Till now, was it clear in the question understanding? Do you guys have any kind of doubt? Can I get a quick confirmation in the chat box? A quick +1 in the chat box, okay? And now, if you have understood the question, I would like to know from the audience what can be the approach to solve this question, right? So, how can I approach this question? And how did you guys approach the question? Yes, Rishit. If it was clear, what are your ideas on how to solve this one? Can I get a single line answer that this is the statement that justifies the entire approach? Okay, it's pretty easy. If you have learned greedy algorithms, then obviously you might have solved its standard questions, right? I hope everyone solves the standard questions of every topic they learn in DSA. So basically, this question is a variation, a kind of variation of a standard question that comes under the paradigm greedy algorithms. Now, in order to find the optimal approach, let's see what can be done. Okay, so now what I'm going to say is that in order to minimize the total number of steps, in order to minimize the over here, we have to minimize total number of moves required to move each passenger to a chair. So in order to minimize this, what I'll be doing, I'll be trying that. So what I'll be doing, so basically I'll be trying to assign the nearest chair to every passenger. So one statement will be assign the nearest chair to a passenger. Okay, so what does it mean? Will this work every time? Yes or no? What do you think? Will this work every time? Let me give you an example. Let's say this is let's say equivalent to 4, and this is equivalent to 9, and over here this is equivalent to 10. And now let's say these are the position of the chairs and these are the position of the passengers. Okay, so now in order to do this, let's say the passengers are present at the position number 8, and one of the passenger is present at the position 9, and the other passenger is present at the position 11. Now in order to find the optimal answer, that is minimum number of moves, what I can do, I will follow the statement that assign the nearest chair to the passenger. Okay, so let's say for the passenger 8, the nearest one, which one is the nearest one, 4 or 9? Obviously 9 is the nearest one. Let's say I'm assigning it the chair 9. So how much will it move? It will move only one step. So for 9, which one is the nearest chair? This chair is already occupied and this one was not occupied. Okay, so let's say I'm assigning this one, right? Every time I'm trying to find the nearest one. If nearest one is not available, then the second nearest one. Okay, and now for the 11 one, which one is the nearest one? This was the nearest, this was the nearest, already occupied. So now it will move to this chair. So now what I did, I chose greedily that every time try to assign the nearest chair. Now over there I can observe how many steps were required, 7, right? in order to move from 11 to 4, and now over here one step was required. So this answer comes out to be 9. But over here this is not the optimal way to assign the chairs. Why? Let's say over here, if the last person was going to the farthest one, no, then obviously the answer is going to be increasing, right? It will increase than the minimize. So basically I should, each and every time you don't have to focus on assigning the nearest one. So for 8 we had two options, 4 or 9, right? So the nearest one came out to be 9, but you don't have to select that one. You have to select the nearest one. If it is present on the left hand side, then go to that side. Okay, so I will be assigning this one. So now here the answer will change a little bit, so I'll be getting 4, and now this will be assigned 1, this will be assigned 1, and this comes out to be equivalent to 6. So now this is how you can get the optimal answer. So basically in the solution you will be in the approach or in the test cases, you will not be given the chairs and arrays. I mean the both of these arrays will not be in sorted manner, right? So over here, in order to find the nearest one, so what I'll be doing, I'll be focusing on uh, going to the farthest one. Like let's say for 8, 4 was the farthest one, right, on the left hand side. And now if the person after 8 tries to reach to this point, it will consume more number of steps. So basically choose the left hand side if it is possible and the nearest one. So what I'll be doing, I'll be sorting both these arrays. So I will be sorting both these arrays. So after sorting, you'll be getting a sorted array, and now you have to select that this position, whichever is the nearest chair, this will be the nearest chair to that person, jth person, and it will be giving you the optimal answer, right? So in this manner, we need to solve this question. That every time you simply have to, let's say you have an answer variable, and now you are iterating after sorting both these chairs and pairs. Okay. So now what I'll be doing? Just a minute. Okay, so let's say I have an answer variable which will be storing the minimum number of moves. And now what will be the answer for each and every person? So that would be the absolute difference of the ith chair and the jth passenger. Okay. So I will be doing, let's say the first array is called chairs, right? I'll be calling it as chairs minus passengers array. Okay. After sorting both the arrays. After sorting both the arrays. Sort the passengers array and chairs array. So this will be the first step of the algorithm, and this will be the second step, and the third step is going to be printing the value of my answer variable, and that's it. So in this manner, you can get the final answer. So was it clear to everyone? Can I get a quick +1 in the chat box? And then we'll be ending the session after coding the solution. Now, what will be the time complexity of this approach? Okay, so if you have understood, +1, and write down what will be the time complexity of this approach. So let's analyze the time complexity. Over here, you can observe the first step, right? So this will be sorting. Let's say the best sorting algorithm n log n, right? And now over here, answer is the summation of absolute of chairs of I and passengers of I, right? So basically, you need to keep on adding this value, and this will be iteration over the total array. Could you please explain the intuition of sorting with one more example? Okay, so let's take one more example. Okay, I'll explain, but let's complete the time complexity analysis, right? So after printing takes constant amount of time, and the overall time complexity comes out to be big of n log n. So this is my time complexity. And what about the space complexity? Anything extra required? No, I'm ignoring the space required by the sorting algorithm, and the space can be taken as constant because answer variable is not going to utilize any kind of space. So this is what my time and space complexity of this approach is, right? And it's exactly similar to the expected one. So now what we can do, we can, let's say you wanted a solution, like you want to understand with the help of an example. Let's say this is my chairs array and this is my passenger array. If you have any doubt in the time and space complexity part, do mention down the chat box, right? So now let's say chairs. Let me give you one more example. Let's say this was 4, and this was 9, and this was equivalent to 12, and this was equivalent to 30. Now what I'll be doing, I'll be assigning, let's say this is equivalent to let's say 8, this is 8, and now let's say 14 and 17. So now in order to solve this, so already assume that the array was not sorted. I calculated this test case and I gave you in a sorted manner. So after sorting, let's say for a test case, this is my condition of the array. So now in order to get the answer, what I will be doing, I'll be choosing the maximum. I'll be doing the subtraction of the absolute difference of chairs and position, or the passenger's position, right? So absolute difference of this 8 and 4 will be equivalent to 4, and now 8 and 9 will be equivalent to 1. This will be equivalent to 12, I mean sorry 2, and this will be equivalent to 4, right? And now this comes out to be 8, 9, 10, and 11. So answer comes out to be 11. You keep on adding this value. Now you are not, I guess someone is not able to understand why this will work. So basically the idea is that, let's say there is a person standing over here. Let's say this is my number line. Now this is the person, and now on the left hand side of the person, this is my starting position of the x-axis. Okay, 0 origin. Let's say a chair is present at this position somewhere, I'm not noting down the value. Okay, and let's say there is one more person uh, standing over here, and there is one more chair at this location. So now let's say this now let me give you the values as well. Okay, so this is, let's say 2, and this is equivalent to 9, this is equivalent to 14, and this is equivalent to, let's say 17. Now in order to assign, you have two values, right? You have to follow greedily that each and every person will be given the minimum, the nearest one. So let's say for this person, nearest one is which? This one. This distance comes out to be 7, and this comes out to be equivalent to, let's say 5. So obviously you will select this one. But if you do in this manner, no, what will be the answer? Let's see, you are following this pose. So this chair is already given to a person. So now 5 moves were taken by a passenger, and now this passenger has only one option. This is already occupied. It has to go to this chair, and now this will increase the total number of moves. So what will be the difference? It will be equivalent to 15, and this comes out to be 20. So the idea that to assign the nearest chair for every passenger doesn't mean the distance needs to be nearest. Okay, so over here, as you started assigning chairs for this passenger, the answer came out to be wrong. Now if you have started by assigning chairs from this passenger, the answer would have been different. Okay, so in order to handle this ambiguity, what I will be doing, I'll be sorting it entire array. And if you take many different test cases, you will be able to figure out, okay, so on sorting this corner thing can be handled very easily. I hope this made the intuition part clear to everyone. Was it clear, Rishit? Can I get a +1? Okay, a quick +1 in the chat box if it was clear. And now let's start the coding part. Okay, so let's code the approach. The solution is very easy to code it down. Let's say I'm coding in Java, but I'll give you what can be the algorithm. Okay, so basically, first of all, first step is to sort both the arrays. Arrays, which arrays? Chairs and passengers. Okay, so there is an inbuilt method, right? So chairs arrays, and sort the. Okay, so I have sorted both the arrays, and now I need a variable to store the answer. Okay, now I need the iteration, right? I need the absolute difference between both of them. So I'll be calling the absolute function method.abs, and I'll be doing chairs of I minus passengers of I. And at the end, whatever is the value of my answer variable will be returned as an answer. Now quickly let's see the compilation, if we have any compilation error or not. Okay, so what was the compilation error? Okay, so basically I forgot to add the difference to answer variable, right? We need to add the difference to the answer variable. The number of moments will be calculated in that manner. And now let's again compile and run. And it is working perfectly fine. Let's submit it and see the answer. So over here, the expected time complexity was n log n, right? And we achieved that n log n by simply sorting it. And the auxiliary is order of one in this approach. So this is the entire solution. Let me share the solution link in the comment section. So I'll be referring to GFG IDE. Okay, was the approach clear to everyone? Can I get the coding clarity? Like, was the coding implementation part clear or not? Okay, so this is the solution which we just saw right now, and I hope this was clear to everyone. Okay, thank you, Rishit, for the confirmation. So, if you have any doubt, if you're watching this session after the live is over, then if you face any kind of difficulty, do mention down in the comment section. I'll be replying over there as well. And if you need any kind of guidance, then you can connect with me on LinkedIn as well. Okay, so that was it for today's session, and let's meet in the uh, next problem of the day. Okay, so thank you. Thank you for attending the session. It was great interacting with you. Bye bye.